So now we're working on question B for problem 2.3 in kaleidoscopes, hubcaps, and mirrors. And what we're asked to do is to take this image, and we're given this arrow, and the arrow represents the direction and distance that we want to translate this image. So here's the direction, and the length of the line represents the distance. So two things we need to know for translation is direction and distance. Now I'm going to go ahead and measure the line so we know how long that line is, because that's telling us how far to move this. So if you look, the length of that line is 5 centimeters. So what we're being asked to do is to translate this image, all of these points, 5 centimeters in that specific direction. And so one of the things I'm going to do, actually, since I know that the distance is 5 centimeters, I'm going to write that over here. 5 centimeters is my distance, and then my arrow gives the direction. I'm actually going to use this line here as a reference point. So I'm going to go ahead and go back to the other end of the arrow and just go ahead and mark a spot on my shape here, right here. It's not a given point, but then I'm going to go 5 centimeters away from that point. And really, we can take any point on this shape and translate it 5 centimeters in that direction, and we'll get a new point. So that point I just put there is 5 centimeters from that point in that direction. So I know that point is on this line CD. And so that just helps me to find a reference point. In fact, I can find a number of reference points using that same method. Now I'm going to go ahead and try to find point C and point D first. In other words, I want to try to make sure I'm going in this specific direction, so I'm parallel to that line, and then I'm going to put my ruler on C and make sure that I'm in line, and then go 5 centimeters from that point. I'm actually going to draw the line parallel to the original, this one here, and that point should be C prime now, if I'm parallel to this line. And one of the ways I can check is distance. If point C is 2.2 centimeters from that point, then point C prime should be 2.2 centimeters from that point. And it looks like I'm pretty close there. So that's one way to tell if I'm parallel to that spot. Then I'm going to do the same thing with point D. I'm going to go the other way because I want to be able to keep this line as parallel as possible to this original arrow that's telling me how to move this. Everything is going in this direction at this angle, so I need to stay as close to that angle as I possibly can. And it looks like if I go 5 centimeters from point D and I stay parallel to that line, that's going to take me right to that point right there. I'm going to go ahead and draw the line connecting D and now what I'm going to call D prime. And I can check and see if that spot is accurate by measuring from this reference point that I drew here to D, and it looks like it should be about 3.2 centimeters, 3.3 centimeters from that mark, and it looks like we're pretty good on that, about 3.3 centimeters from that mark. And so now I'm going to go ahead and fill in this line right here. So I think that's the first part of my image. That's the C to D line, copying this line here. And so now I want to try to find some of these other points on here. And so I have some points of reference, lines of reference. In fact, B, looks like B is almost on this line, pretty close. And so if I now try to find the location of B, 5 centimeters, right in that direction, staying in line with this line, putting the ruler edge on B, and then again it looks like that line is pretty close to right down the line of B, and then go 5 centimeters from B right to there. Yeah, it looks like I'm pretty close to my line. So right there would be B prime. And then if I want to find E, I'm going to go the other way because again I'm trying to keep my ruler along this line so I can keep it parallel or keep it straight. And so if I go 5 centimeters from E to this point, so E prime should be right about there. So I'm going, in this case, 5 centimeters, and each of these is 5 centimeters from the original point. 5 centimeters. D is 5 centimeters. So every time I do one of these, they're 5 centimeters from the original point. And then I think I can check some other points here. That looks like that's about the right distance. So now I'm going to go ahead and connect D, and this is E prime. And C and B prime. Just connecting dots now. They made. Actually, go ahead and draw on the line here, an E to E prime that was 5 centimeters long. Because I'm, again, just connecting original points to new points. And then now I need F and A. So I'll go ahead and do A first, see if I can get that one in the right spot. So I'm looking for a point that's 5 centimeters from A, in line, parallel to this line again. So all these lines, see all my lines, I'm trying to keep this ruler at this angle here. And I could measure it with an angle ruler to try to make sure it's perfect. I think we can see how our lines and our rulers, you just use lines that you have. And so that point A should be 5 centimeters from that point. So right there should be my now A prime. And that connects up to B. So try to keep track of all these lines. And now you see how the image and its translated image, when you connect up all these lines, you start to see lots of symmetries in this. So now I need F and F prime. And I'm going to flip the ruler for this one so that my ruler stays more in line with other lines that I've already drawn. So if I look at F, 5 centimeters from F prime, keeping the ruler in line with all these other lines that have been drawn. So right there should be my F prime. And draw the line to it. And so now that's the last point I needed, so now I can finish connecting dots, A prime to F prime, and then F to E, F prime to E prime. And it looks like, kind of get cool looking images when you do this because you're in a sense making a 3D image. As you translate the original image from its original location in that direction, 5 centimeters, all of these points then are translated directly to the other points. Every point on the original is now repeated throughout the new image that we just created. So we took the original image, moved it 5 centimeters in the direction of the arrow, because the arrow is 5 centimeters long, and it gave us a direction to move it. And with that, then we have a translated image from the original. Translation literally is just like taking the piece of paper and sliding it one direction or the other. And in this case, we were sliding it down to the right, and so we got the new image down to the right from the original image. When you translate a figure, you can really visualize it like you're translating the entire plane. The plane is, flat surface is called a plane. And so it's like you're moving the plane, the flat surface, you're taking it for a ride. You're moving it along here. It's just sliding over. And none of the original points are unmoved. If you notice, every point from the original has been moved to a new location. So there's no original points that are still where they originally were. In a translation, everything moves. There are no fixed points in translations. Every part moves. And that's really all we have for problem 2.3.